All right, what's going on, you guys? Welcome to another video on prime logic. I've got a really interesting and challenging geometry problem for you today. So if you want to solve this problem, think about it, please pause the video because I'm going to solve this problem right now. So we have a semicircle here, and what we've got to do is just to find the area of this shaded segment, which are colored in red. So we have this shaded area here and another one, this cap here. So obviously we don't care about this unshaded area here. And the only assumption of this problem is that this chord, the length of this chord to that chord is free. And we have this point, so we have 1, 2, 3, 4, 5, 6. So these points, they are equally spaced. It means that the angles between them is just 30 degrees. So these points are on the circumference. So this circumference, the length of this arc, these arcs are the same. So the first thing, obviously, we know that the angle here is 30 degrees because they are equally spaced according to the assumption of the question. So this is just 30 degrees. So let's name this radius as r. Okay, so we know that, and let me draw kind of a perpendicular line here. So this is like, okay, so assume that's perpendicular. So we know that the cosine of 30 degrees equals, so this side adjacent over r. So cosine of 30 degrees equals, so this adjacent side equals to this side, right? So because this is a right angle, this is a perpendicular here, and so is this radius, because they are 90, this is 90 degrees, so this is 90 degrees, so this forms a rectangle here. So we know that this is perpendicular. So if a radius is a perpendicular to a chord, so this bisects the chord. So if the length of the chord is 3, so this length is just 1.5 or 3 seconds. So we know that the cosine of 30 degrees is this adjacent side, which is 3 over 2 over r. So it is just over r. So based on this formula, we know that, so r cosine of 30 degrees equals 3 over 2. So we know that the cosine of 30 degrees equals to square root of 3 over 2. So let me write it here. So r square root of 3 over 2 equals 3 over 2. So it means that, so r equals 3 over 2 over square root of 3 over 2. So they cancel each out. So r equals 3 over square root of 3. So if we multiply both numerator and denominator here by square root of 3, so what we have here is 3 square root of 3 over 3. So we know that here r equals to square root of 3. So that's the final answer for r, obviously. So what we know now is the length of the radius is square root of 3. So one thing here, so we should divide this shaded area into multiple parts. So the first part we can say here is to find the area of this sector here. So this is like a slice of pizza. So this sector here and this sector here, they are just the same because their angle at center is 30 degrees. So we can obviously calculate this segment, the sector here. That's very easy because we know the the angle and we know the r. And we have here, if you take a look at it here, so we have a very big isosceles triangle. So the sides are r, and here we have the length of this chord here is 3. So we have everything, so we can use the formula for any triangle. So we have the sides and we have the angle here, so we can use this trigonometric function and values for solving the area of this triangle. And for what about its cap? So the cap we can also say, so the formula, the methodical and fundamental approach for calculating the area of the cap is just to calculate the area of this big sector. So we have 2 slices of pizza like here, so they are the same. And then we subtract the area of this triangle. So we have a triangle here. Obviously, we can calculate the area of this triangle. Then finally, what we'll have is the area of the cap. So we have area of these 2 slices, these 2 sectors. We have the area of this big triangle, and we have the area of the cap. So let's see what we will find here. So the area of this slice is, okay, I'm going to write it here. So the area of this slice, equals to 30 degrees over 360 pi r squared. So that's 1 over 12 pi, and r is square root of 3. So r squared is just 3. So they cancel each other, the numerator and denominator. So what we have here is pi over 4. So pi over 4 is the area of one slice. An area of 2 slices is, so 2 times this, which is pi over 2. So far we found the area of these 2 slices. So that's pi over 2. So what is the area of this big isosceles triangle? So we know that the angle here is just, let's count the angle. So that's 4 times 30 degrees. That's 120 degrees. So 30, 60, 90, 120. So let me write it down here. So we know that the area of any triangle, if we don't have the height, so we can say the area of triangle equals, so that's A, so 1 over 2 or 1/2 AB sine theta, right? So that's area of this triangle is A and B, they are the same because that's the radii, so r squared so here is r squared sine theta. So again, it equals to 1/2 r squared is 3 because r is square root of 3, and sine theta. So what is the sine of theta? So that's 120 degrees, right? So here we have this trigonometric circle here. So we know that, so if you are kind of confused here, so we know that this is, so if this is a radii in the moving radius here, so that's 30 degrees, 60 degrees. Let's use this with this marker. So we know that this is, the sine is the y value. So as we are moving towards 90 degrees, the y value or the sine becomes 1, and then again it is decreasing as we move to the second quadrant. But still, the sign is positive because we are still, the y's are positive here because we are in the second quadrant. So we can say that the sine of 120 degrees is the same thing as the sine of 60 degrees, right? Because this is the sine, this is the sine, this is the y of 60 degrees, this is the sine of 60 degrees. It is the same thing as the sine of 120 degrees. And we know that the sine of 60 degrees is square root of 3 over 2. So Okay, so square root of 3 over 2. So the area of this triangle, this big triangle, is 3 square root of 3 over 4. So far we found these two parts here. So the area of this triangle, the area of these two slices. So our final step here is to find out the area of this part. So we know that area of the cap equals the area of these two slices. So we have the area of these two slices here because they are the same, right? So the area of two slices is pi over 2 minus the area of this triangle. This is also an isosceles triangle here. So the area of this triangle, so pay attention, area of this triangle, it is the same thing as the area of this triangle that we found, but let's compute it again because the shapes are a little different. If you use your spatial geometry, we know that all these triangles, they are congruent. So no need to compute it again, but let's imagine you don't notice this congruency of these triangles here. So imagine if we put this triangle, if we take it and we map it over here, so it becomes the same shape as here. But let's assume we don't know this area of this triangle. So area of this second triangle equals, so 1 over 2 or 1/2 AB, which is the radius, or r squared, or 3, and then sine theta. So what is the sine theta? Here the sine theta is not 120 degrees, but 60 degrees, which is the same as I mentioned before. The sine of 60 degrees is the same as the sine of 120 degrees. So the sine of the sine of 60 degrees is just the same thing, square root of 3 over 2, right? Which becomes 3 square root of 3 over 4. So sorry if I calculated again, but for those of you who just want just a methodical approach, no matter what, so this is the same thing, right? So now we have this area here, and we have the area of the two slices here. So the two slices, the area of the two slices was pi over 2. So let's write it down here. So area of cap equals pi over 2, because that's the area of these two slices or sectors, minus the area of this second triangle, which is 3 square root of 3 over 4. So that's the area of the cap. So now the last step is just easy, just to do some algebra here and adding and subtracting things. So okay, I think we can write it down here. So the area, the final answer, the final red area equals, so we had two slices here, which was pi over 2, plus we have the area of this big triangle, which was 3 square root of 3 over 4. And we had the area of the cap plus pi over 2 minus 3 square root of 3 over 4. So they two cancel each out. So the answer is 2 pi over 2. So the final answer here is just pi. So that's the final answer. Obviously, that's not the only way. There are numerous, countless ways to do that. So if you are here for more like faster shortcut version, so this one was a more methodical, fundamental approach for most students. They prefer this way. If you prefer more intuitive style of calculating the areas using geometry, for example, you can use your spatial or geometry, because for example, these triangles, they are all congruent. Then you could say, for example, instead of these two triangles, you could calculate instead of these two triangles, you could calculate these two triangles, right? And that would be way easier, because in that case we have 1, 2, 3, 4 slices. So we had here, we calculated the first slice. Each sector is pi over 4. So we have 1, 2, 3, 4. So 4 times pi over 4, that would be just pi. So that's maybe the second approach, which is way easier. All you need to do is just to find out and to prove that these triangles are congruent. Of course, there are a lot of other approaches. For example, you could use calculus, you could use integration, because now we have the r here, we have the radius, so you could write down the formula for the circle or the semicircle, for example, x squared plus y squared equals r squared equals 3. Then you could write, for example, the formula in terms of x, because we want to integrate not horizontally but vertically. Then you could use some bounds here, for example, from y0, and then we have another y. So the y here is at square root of 3 over 2. Then we have another one which is at another one which is 3 over 2. So you could use, for example, this bound to this bound, this bound. So there are a lot of ways. So maybe that's a bonus challenge for you. A challenge for you is to use integration. So I want to check if anybody can solve this, a complete, correct, and just answer using integration. So please write it down in the comments below. So that's it. That's going to wrap it up for this video, guys. So if you like this video, please subscribe if you haven't already, and make sure to like and comment your thoughts in the comments below. And as always, I love you guys. I appreciate you guys, and see you in our next video on prime logic.